Okay, then we kick it off then. So, hello everyone, and welcome to this webinar. We just give it 1 or 2 more minutes so everyone is able to finish their lunch before we kick this interesting topic off about AI-based testing of AI-based systems. But yeah, 1 or 2 minutes more. Okay, let's kick this off. Welcome everyone. My name is Magnus. I'm working here at System Verification for many years now. I think it's 14 or 15. So I can't actually really remember. But I've been working with mostly with process improvement, but been in the area of quality assurance and software engineering for more than 25 years now. Last week, I was down to Lisbon at the international conference software engineering, and that was the 46th one in the row. So it has been going on for a while, and I would say it's a very, very big conference with lots of different tracks and speeches. Many interesting topics that was highlighted, but as you can imagine, one of the major areas that people were talking about was, of course, AI, machine learning, large language models, and how to train, how not to train, and how to fix things, where they can be used, etc., etc. So, therefore, it's going to be very interesting to listen to Igor's presentation today about approaches of testing AI-based systems. Igor has been also working with quality assurance for a while now, 10 years, and been with system verification for 3 years. Started off with manual testing, as most of us have done, but then moved into the test automation and working with CI/CD and DevOps and things like that. He has been working in a number of different areas, and now he's also working on taking care of test environment, stability, implementing web service mocks, and so on in his latest projects. So it's going to be really interesting to listen to his presentation about this type of testing. Just before I kick it off, some formal things. We will wait with the questions until the end. So please, if you do have any questions, put them in the Q&A and not in the chat. If there's something very important or something you would like to comment on, of course, you can put it in the chat. But questions, please put them in the Q&A. And with that said, I hand it over to you, Igor. Thank you very much.
Yeah, hello and welcome everyone. I'm very excited to see you all on this webinar. We are trying to touch this very buzzwordy topic of AI. Basically, a new player in the town, and a lot of things about it is unknown. The entire topic is very complex and might cause some hesitation, some even impediments for people to even approach it. It seems sometimes could seem very like intimidating to even start looking at, to start diving into. I think that the aim of this webinar would be to try to break the ice around this topic, to make sure that after it you will be able to understand that the entire the entire area of AI is very not only interested but also approachable and could be the next step for you in your career. Now, when I'm talking about this intimidation and approachability, I'm basically talking about my own impressions because for a long time, this topic has been something that I've been hesitating and postponing to dive into simply because after having years of experience with conventional software, this new AI area seemed so much different and had so many concepts, new concepts, which a person would need to fit into his or her head, that it actually seemed very over the top. And basically, sometimes you didn't even know from which side to start digging. So let me start off with this idea that what we'll be doing is we'll start to dig into this topic step by step. The first step would be to understand what is the difference between the conventional software that we are so used to and we have a large amount of experience with compared to AI-based systems. That will bring us the understanding, which will be the first platform from which we'll jump into the more deep subject of the topic. So, first of all, a small disclaimer. So, whenever we will be talking about like this AI-based system, we are talking about machine learning, basically. The many courses around the web start their descriptions, and the first lesson is basically related to dividing into these areas and sub areas of computer science, AI, machine learning, deep learning, etc. I'm not going to go too deeply into that. What I'm going to say is that AI is part of computer science and machine learning is part of AI. It's not the only AI way to achieve the artificial intelligence, but this way was the reason why we have AI as a buzzword, basically because the last few years, the main accomplishment that have been around on the web and in the news have been accomplished due to machine learning and deep learning in particular, which is just a sub area of machine learning. Another point is that when we will be talking about QA and testing in particular, we will be taking into account the black box testing. Yes, machine learning could be also tested with the help of some smaller white box tests, but we will not go into details about that. We'll look at it from the higher level perspective of us as a QA engineers or possible developers trying to just make sure that the model is behaving as expected. Of course, we'll dive into the terminology a bit later as well. Now, let's just split this entire understanding of what seems so unapproachable in this topic of AI into three categories. So basically, first of all, is the lack of transparency. So yes, we don't really know how the internal system works because it's not just a bunch of ifs then statements that are clear to our eye when we look into the code. And it certainly doesn't help that some developers of the AI-based systems, when they give their interviews, they themselves admit that they don't really know for 100% why that or this decision has been made by AI-based system. So yeah, the transparency might be lacking, and that adds up to the level of complexity that the AI system have. They are very complex. Sometimes we hear numbers of like a billion of parameters that are input into the system, and that is not even the biggest number that you could possibly hear. So again, just imagining how much of processing is going on inside just doesn't fit into the human brain, basically. Now, another point is the probabilistic nature of such systems. Probabilistic means that the answer that the system gives, it is basically a guess based on statistics, and the system tries to guess which answer would be more fitting for the current question, with the highest probability of it being the most correct one. Now, if we have such system and each answer is a bit different than the previous one because of the probabilistic nature, how do we test it? Now, those issues we'll try to break down and to dissolve our hesitations using some story time. So let's jump into this fictional story of a mathematics teacher in a middle school. He's a very organized guy. He likes his job. Each time he enters the classroom, he likes to check his gear. He makes sure that his clothes are tidy, that the chalk is ready to write on the blackboard, his pens are ready, and that his calculator is operational as well. He turns it on and off and goes even one step further. He inputs 2 plus 3 and expects the results to be 5. Now, this part of story is very much like the QA engineers interacting with the conventional software. What we have here is basically a set of parameters. They are pretty solid and defined. And of course, the output of the system is also solid and defined. We expect an absolute value of 5 when we input 2 plus 3. That is how we've been interacting with conventional systems for decades now. Now, back to the story. The teacher arrives at his job and a strange situation happens. The English literature teacher from the neighboring classroom is absent, and our mathematics teacher is asked to substitute her for one lesson. Of course, he refuses at first, but then he learns that the topic of that lesson is his favorite book by Charles Dickens named Christmas Carol. Now, it is a Christmas fairy tale, basically. The storyline goes about the selfish and greedy guy who one Christmas night happens to meet 3 ghosts of his past, of his present, and his future. They show him the wrong of his ways, and he realizes how incorrect he was towards his peers, environment, etc., and tries to change himself, basically setting his foot on a path of redemption and becoming a decent human being. So our teacher enters the classroom and starts checking the homework of these students. The homework is basically to read the book, understand it, and his question to each of the students is to just describe the entire idea of this book, the storyline, and what is the gist, what is the summary, basically. The students are answering one by one until our teacher gets profoundly confused by one of the students, which gives him a very unusual answer. He says that this book is about a bad guy getting away without any punishment. Now, first of all, the teacher dismisses the student. He just thinks that this student hasn't even read the book in the first place and he didn't complete the homework. But having engaged with this student in a lengthy discussion, he discovers that no, actually, this student have really, technically speaking, completed the homework. The book is read, it is understood, it's only the output, the entire impression of this book is something that feels wrong. Now, this part of the story is about a QA engineer that is interacting with AI-based system. The problem with AI-based system is when we test it, we do not get the absolute value back. It's probabilistic, it's non-deterministic, which means that each time we input some value into it, the output value cannot be described by some expected concrete value. Rather, we can assume that there will be some range of values. Now, if it comes to this story with the teacher, he is supposed to put a mark in the diary of the student. And now, what mark does he put? Technically speaking, the student completed the homework, but the answer, the summary, and the idea of the book is somewhat wrong. This is the point where, in terms of AI-based system, the AI engineers would go in and try to correct the system. By correcting the system, meaning changing either the data or the algorithm that analyzes the data. Now, in our particular case, the data is the book. We cannot change the book, but we can change the algorithm. We can put the weights and distribute them in such a way that the system starts understanding the data the way we want it to be. Now, in case of the teacher, that would require him engaging into lengthy conversation with the student, actually explaining him what this book is about, and discovering that it turns out that the student, when reading this book, for some weird reason, put a lot of emphasis on the first 10 pages of the book and the last 10 pages of the book. And the middle part of the book, for some reason, gets omitted completely from the overall impression. Now, after the teacher has explained the student about how middle part is equally as important as the beginning and the end, the student returns to the classroom a week later with completely different knowledge and the impression of the book. The book hasn't changed. The impression in the pupil's mind has, though. So, having said that, let's look into the nature, how machine learning's process of cognition differs from the human way. So machine learning systems ingest data as their source of learning. By ingesting, I mean, we basically feed the data into the algorithm. The algorithm is very complicated. We won't go into that. But the entire result of this process is a model, something called a model. It's basically the result of data being processed by the algorithm. Now, if we compare it to what humans do, the process is somewhat similar. So we have an interaction with an object or some activity. Our brain perceives it and leaves a static trace of concepts, ideas, impressions, memories in our container called memory, right? And basically, the funny part of that is that the next object or concept that we are getting in touch with can be processed and can be affected by the concepts already present in the brain. So the entire purpose and like the premise of the machine learning is basically trying to copy the way the human brain works. Now, if we go into this process into more detail, we could just the way I try to simplify this understanding is that machine learning process is basically just a conversion of data into the model. It is possible thanks to the algorithm, and the algorithm kind of produces the model using the training data. Now, algorithm, like what is the main way the algorithm does that is looking for patterns in data. Well, actually, that's very similar to how children learn. For example, if you, as a child, see a small boat and a huge cruise liner, whenever you see a middle-sized yacht, you would assume that this floats as well. You could even assume the speed of it just from by the looking of the waves it makes. And now that is the trait that also is common to machine learning models. So model can make predictions about before unseen new set of data. Now, when we are talking about data in terms of human nature is just experience, right? So experience kind of translates into data in terms of AI systems. Now, let's look at the process of creation, because software development lifecycle is a bit different for AI-based systems. And the main difference is that developer doesn't really make the end product. So in the conventional software, we have requirements. Developer knows what to do due to them. It produces the developer produces code, and the code is just technically compiled to make a product. Now, in terms of AI-based systems, the requirements and developers do somewhat similar thing. The result of their work is algorithm. Now, algorithm is in no way an end product. Algorithm is just a way to analyze data and to give birth to this thing called model. Now, model is much closer to the product itself. It is just covered with some pretty stuff and basically a way to interact with it, and that is what we call a product. So the main outtake from here is that this is more complex way of producing software, and the developer isn't really responsible for the end product. He is in some way, but the algorithm is what directly affects the model. And the second outtake that we could notice is that if requirements in the conventional software were very important to be of high quality, because if they are not, we need to go through this cycle of development and code and deployment again, then here it's even more so, because whenever we go through this cycle again, we need to not only develop the algorithm, but also to train it again. Now, input the data into it, which will yield the model, after which we can deploy the product. So requirements are of the utmost importance here. And let's look at the QA challenges that we've got regarding the AI-based systems. First, of course, are the poorly specified requirements. So that could lead either to developing the wrong type of system that we actually intended, or very challenging QA process. Of course, one of the challenges for the testers is the system being non-deterministic. So basically, different result each time, right? We have a probability, and we need to deal with that. We need to deal with the values, output values, which are not some set in stone, but rather a range of values with some margin of error, which complicates the entire process far more. We'll look into that deeper later in the presentation. Now, complexity, right? Again, these billions of parameters and the problem that things that the systems do frequently cannot be rechecked manually, even one time, because the system that does a prognosis of some very complex process, or like a foreign exchange for the next year, how could any person know the answer to that? And how could any person actually verify that the answer that the AI system gives us is correct? Now, next challenge is the self-learning systems. Those are like the pinnacle of the AI-based systems, right? Let's not forget that not all AI-based systems are self-learning. It's actually frequently not even advised to have a self-learning system in case we are limited by some regulations, for example. Because in the self-learning system, the problem is that we don't know which direction the system will evolve into. Sometimes it can even devolve, so become worse than it was, while thinking that it is making things better. Now, the problem with self-learning is that there is too little time for the newly born model, and these iteration of the birth of new model come faster than we come up with the test cases, right? So the entire process is that like self-learning model would be self-learning system would be producing the model, then assess how effective it is, learn from some changes in the environment, and then retrain the algorithm with the data in order to yield the new model, which substitutes the old one. So again, we need to keep pace and basically manage to test it before the newly born model takes place, right? Now, the last point is open to interpretation. That is because some answers from the systems and some systems give answers which are just subjective. Basically, some people like to hear that answers, and some people might consider those answers as wrong, and that might be challenging to test as well. Don't forget that we have many systems which are not giving us some digital values at the end, but some like free form responses like ChatGPT, for example. Now, let's dive into something much more solid and rigid, which are the quality characteristic of AI-based system. Those are things which are pinnacle, basically, around which we are centering our testing process. We are testing flexibility, adaptability, autonomy, self-learning, bias. Now, those are not all of the quality characteristics, because some of them go further into area of philosophy. For example, there is such a quality characteristic as ethics. I won't go into that because I guess it's more of an area for philosophers or lawmakers rather than us technical people. So these five: flexibility is an ability of system to operate in situation which were not foreseen during the requirement process. Now, the problem with flexibility is that the system needs to recognize that the circumstances have changed around it, and it needs to engage some new mode. So, for example, the self-driving car needs to know how to drive through the fog, and it needs to understand that this is the fog and not just some dimmed glass of its camera, right? The flexibility is a crucial component in self-learning AI-based systems because, basically the next iteration of the model that is being born happens exactly after the system understands that the circumstances are new, and that's the way to improve it. Next quality characteristic is adaptability. It's very similar to flexibility, except for the fact that flexibility is something that is an innate characteristic of the system itself. Adaptability is rather about external change. So basically, AI technicians come to the AI-based system and improve it by adding more sensors, for example. So they adapt the system, make it better, but with the external help. The characteristic kind of describes the ease of modification, right? Autonomy is ability to work by itself, and the characteristic which is very important in terms of how long can it actually stay by itself, and whether it stays by itself not too long, because we would not like our systems to actually yield control to us after some time. And if it comes to self-learning systems, the self-learning quality characteristic, or evolution as it's sometimes called, is basically characterizes the ability to improve in response to the circumstances. And the bias. Bias is just a very hard to grasp but very impactful characteristic. The thing about bias is that we can get an AI-based system which tends to give certain types of advices or response in versus some other response, which isn't really grounded in some real data, but just rather some bias, which is kind of subjective opinion of the system itself, which we try to avoid, of course. Now, if it comes to requirements, let's get back to this very important topic, because QA of requirements in AI-based system seem to be much more important and much more robust than the regular conventional software. We need to know which requirements do we need to focus on corresponding to each of the quality characteristics. So flexibility, for example, needs to describe clearly and precisely to what extent the circumstances are expected to change. Of course, we don't know how they will change, but what extent is kind of plausible, and we think that after that extent, after we like cross the limits of that extent, the system should, for example, yield control back to the pilot. The adaptability, again, it's about people who actually engage and improve the system. The characteristic would be how much time effort it takes to adapt it. Autonomy is amount of time the system is able to operate on itself, and of course, not least important, the conditions when the system should yield control in the end. Self-learning is a characteristic that and the requirement for it that should mention what amount of changes are allowed to inflict on itself. The changes, of course, we don't want the system to override itself by itself, basically, right? The bias is the requirement for bias are pretty not that solid and clear as all the previous one, but the requirement might be more related to the data, to the training data that we have, and we need to see what the quality of it, what the sources of the data, and of course analyze the parameters, the weight parameters from the algorithm that is analyzing this data. In case of our story example, the book hasn't changed, so the data hasn't changed. But the student has been introduced new weights into his learning system, which produced a new model, which is basically has changed the impression of the book profoundly. Now, if we go a bit further into the acceptance criteria and test approaches for each of these quality characteristics, we would see that flexibility should have clearly defined the amount of time and the way to the amount of time that it takes to start operating in the new circumstances. But the way to test it is actually to create a suite of functional regression tests and measure that time, right? That suite actually can be automated. Adaptability, again, it's about people who change the system. So again, time and resources used to adapt. And the same functional regression suite could also cover that and reveal some defects there. Self-learning is the acceptance criteria for self-learning would be that the system evolves and still meets the requirements. At least it doesn't devolve. So corner cases in this case become much more crucial to test by and covered by our test cases. Autonomy, again, the test cases of that kind of quality characteristic need to focus on exceeding the limits and see how the system behaves, whether it yields control back to the human, and if we do not exceed the limits, does it have the possibility to convince itself to give back the control while it shouldn't actually. Now, the side effects is the common term for some very unexpected outcomes, like, for example, the self-driving car who starts moving through the lawns and the pedestrian zones. Basically, this acceptance criteria is fully risk-based, and we're just trying to assess what behavior is the more probable to happen, the harmful behavior, I mean. And the test cases need to focus on colliding the priorities of the system to try to provoke it to actually produce some side effects. The reward hacking is a very interesting quality characteristic. Basically, it's an ability of a system to fool its own reward function. The reward function is the mechanism which tells the AI-based system that it does good thing, and basically that's the way of AI to distinguish what is good and what is bad. Now, reward hacking would be, for example, cleaning the house, and instead of cleaning the house, the system could even put more dirt onto the floor to clean it even more, and then that way the reward function would get even more rewards because of much more dirt gets cleaned. So basically the system tries to hack the reward function to get more and more bonuses for its own job, while actually not meeting the expected behavior it should be doing. So multiple independent tests will cover and mitigate the risk of having the reward hacking in the system. And of course, we need to kind of have the assessment of the system's success in form of multiple factors, not only the one. For example, the amount of dirt being cleaned from the floor. Bias is a very difficult topic. Again, we can possibly test bias with a bias-free test suite, bias-free data. But again, where do we take this bias-free data from? We should assume that any data could be biased. So again, if it comes to such systems and test cases that we could possibly implement, those would be, for example, in a credit scoring application, the color of the eyes of the person shouldn't affect the color, the credit scoring, right? So what we could do is to feed it to similar data sets, just switching the eye color and making sure that the results of the credit scores are the same within a certain margin, of course. Again, we are talking about probabilistic systems, so we won't get the same answer each time. Now, the data. Data is a very important topic for the AI-based system. It is being used in many points of its development. First of all, the training input. We train the algorithm to produce the model, which the model itself is basically our product, which we will be testing against. And apart from that, after the model is being born, we are evaluating model with the data again. So we're trying to evaluate whether this model behaves as it should. Then we have something which is called model testing. Now, that happens only after the evaluation of model is successful. Of course, if the model is not successful, we will get back to the point of adapting either the data itself, the training data, or the algorithm. So basically changing the weights of the algorithm, which understands the data, and then retraining the algorithm again to yield the model. So the next version of the model gets evaluated as well, and the cycle continues until we get the appropriate result with the model. After that, we get to something called model testing, which is a separate testing. It might seem similar to the evaluating the model, but it should be actually completely separate because it needs to be independent of the previous testing. And of course, it should have a different set of data. So every stage we are testing with different set of data, not the training input. And after the testing cycle is complete and we have the model which kind of satisfies our expectations, we need to make sure that the operational data is tested as well. Now, the quality of data is a separate topic, right? It's basically, there are a lot of characteristics to the data which tell about its quality. But also, what is important is the pipeline that feeds the data. This is more of a indirect thing in terms of data, but it also affects the data very much. So if we look at the QA process itself, we need to make sure that the data is from the right source, from all the data that we got from the source. We have chosen the right one and not some extra or some lacking. Now, it should be prepared correctly. Again, the quality of data is a separate topic, and it should contain no bias. So, for example, the some unseen patterns, as blue-eyed people getting more credit score, a larger credit score uh, than other people. Now, back to the pipeline tests. It's just a conventional software basically. So we can test it the way we would usually test. We test the components by itself, because the pipeline is frequently comprised of few transformations of the data, one by one, and each of that should be tested separately. Then we test it together in a system or acceptance tests, and of course we need to take into account the non-functional aspect of that. Now, if it comes to the ML model itself, machine learning model itself, how do we test that? Because again, the entire model is just a result of ingesting a data by the algorithm, right? So what do we need to test the model after it has been birthed? The static test is basically, we are looking at the algorithm that has given birth to this model. Was it selected correctly? Did we choose the algorithm which is up to this task? And of course, the parameters of that algorithm. Now, dynamic testing involves the acceptance criteria and should be held in complete isolation and use separate data tests each time, which has been already mentioned. Now, let's look at the most interesting part, maybe, at least for me, is the concrete like testing methods, and how do we approach what do we actually do with the model in terms of test cases, because of course the way we construct our test cases is completely different from the conventional software. So while some of those testing techniques are actually common with the conventional software, here our approach is much more relativistic, I would say. So we don't have a solid value or some point of reference, what is a good answer, what is bad answer. We would rather compare the two answers and assume that the direction the system is moving is the correct one. So first of all is adversarial tests. Those are basically tests of when we take a data set, the input data set, and change a small value in it. So for example, an image analyzer, we would feed it several images with just one pixel changed in it, and test if the system still recognizes the same object from that photo. Now, it might surprise you, but sometimes the machine learning systems actually are confused by this type of test very easily. So the ball starts to be recognized as the automobile wheel for some reason, just by changing one small pixel. Data poisoning test is basically, we have talked about the data a lot here, and that it's just related to the data which we corrupt. Sometimes the corruption, why we need to test against that is that some malicious intentioned people can actually corrupt the data, the training data, the publicly available data, so that in order to introduce bias into the system. So we need to check sources and analyze the patterns and outliers. The outliers here are the most indicative of some poisoning. A/B testing, comparison testing, proves that the data could possibly be poisoned in case we have any suspicion. Now, combinatorial testing is becoming much more important in the AI-based system as well, because the amount of input parameters, as we mentioned, might be so large that we cannot possibly cover all the test cases. So what we should do is engage into pairwise testing. It's a so-called method when we just take pairs of the parameters and try to create all the combination of the two of the parameters. And while we are not covering all the parameters, it was proven that 70% of all bugs are being uncovered by that method only. Now, back-to-back testing, again, is just a relative comparison of two versions of the same system. So if we have a newer version or a newer model, again, in a self-learning systems, for example, we could run both of those with the same input of testing data and see what the output looks like. And we could actually assess it and see if the tendencies are getting worse or better. A/B testing is just very similar to back-to-back testing, mainly focuses on non-functional improvements. And metamorphic testing, sorry, is the form of testing where we just start with some known test case. We already know what the answer for the test case would be, and we assume that if we, let's say, multiply the input values by 2, then the output values should decrease. And we basically test against that knowledge. And again, we can just uncover some bugs just by seeing that the output increases instead of decreasing. So those are like the most practical ways of actually interacting with QA in machine learning area. And let's now get back to familiar kind of software, which is a conventional software, because we need to understand that the model itself is somewhere in the cloud, and we do not interact with it directly as a QA engineers. What we do, we would interact with it through some means, and that means would the middleman would be of our familiar technology. That would be some kind of API, web graphical user interface, or file streams. And that is something that we have been having fun with for quite some time. And all of that knowledge that we have will be applicable here as well. So conventional parts, of course, go through their own software development lifecycle, right? But ML components go through a bit separate way. We have seen it partially in the slide before, like, for example, the creation of the cycle of development of the machine learning model would involve training with the data, spawning the model, testing of the model, then adjusting if the model doesn't satisfy the requirements. So then again and again. So that is the cycle of the development. And as long as we satisfy the requirement, we could jump out of that cycle and actually continue to join with the conventional software. So let's say we have a data feed pipeline, which is a conventional software. It could be an API or even some Kafka related pipelines. And those are being integrated with the machine learning model and tested in the system integration tests and end-to-end tests. Now, it's worth noting that no component testing for machine learning is present at all. The machine learning is too complex system to even start testing it by one component. So, and if we are talking about the AI components of any system, hybrid system, and most systems are hybrid in some way, we're talking about ML models. So ML model, machine learning model, is placed into some onto some server, which basically does the heavy lifting, but all of the surrounding infrastructure is just the conventional software, which we are very familiar with. Yeah, so I guess that would be it for today. And thank you very much for listening. And I guess now is the time for questions and answers.
Yes, thank you very much, Igor. So yes, we have a few questions here, and we have asking there some more time. The first question is if the model does not perform as it's intended, we see that these deviations, and you don't get the expected results. Which possibilities do you then have to change the model's behavior? Is it are we lost, or can we do something for that?
Yeah, we can do something.
Mhm.
Like as we had this example with the teacher and the student, right? We can adjust either the input data, which would be the book, or the way that student understands this book. So in terms of machine learning mechanism, that would be either changing the input training data, which the algorithm is trained upon, or changing the weights of the algorithm itself. So in the end, either way we will get another machine learning model which will give us different answers.
And then maybe we can do A/B testing with that one as well to
Yeah,
see if
exactly.
that's okay.
That's what we do usually.
Yeah, okay, okay. Okay, thank you very much. Another question here is about what about the legal situation, such as copyright law and things like that? How do we handle these questions when we work with these kind of models?
Oh yeah, that's I think that's subject to change very frequently in the coming years. Because many countries, first of all, they come up with the regulations regarding that, and the companies themselves as well. As of now, it's kind of a gray area. I mean, some pictures which you have seen in this presentation have been generated by ChatGPT as well. So again, whose rights are these? Are those mine pictures, or is it Microsoft's? Nobody knows for now, but basically it's all in process now. We need to keep in mind that this topic is fresh, and the new regulations come in, and many of the issues that we are facing right now are so new that we just need to be patient and to wait for the solutions to them.
Okay. Yes, thank you very much. That's the question that we have received, but we also, yes, we have got some ideas for music to listen to as well in the chat. So have a look there if you would like to get some inspiration, like being a futuristic hacker when you're doing your programming.
Is it machine learning generated music?
Actually, I don't know. Actually, let's can always check after the seminar here, but. Thank you very much for this presentation, and thank you very much, everyone, for attending. Oh, there is another question now. Sorry, before I close down. Yes, final question here. Let's see. Just to like that. Avoiding biases must be very hard since we all have bases in one way or another. Yes, of course. Having a very diverse team should help. What do you think?
Could you repeat, please? Having
Yeah, avoiding biases
Yeah.
is of course hard. So it's always around us in different ways. So having a very diverse team should maybe help. Or what do you think? Could it?
Yeah, the problem with the team is that the team isn't really isn't really affecting the end product that much, because the data does. So what team does is producing the algorithm itself, right? But as long as we feed it the biased data, the output model will be biased as well. So yeah, I guess it's just a combination of testing methods that we have seen here in the presentation, and the opinion of the experts on the data itself and on the output of the machine learning model as well. So this is one of the hardest topics, actually. That's what also has been mentioned, that the acceptance criteria and the overall requirements for the bias are a very vague and not concrete topic. So that is something that data engineers are trying to fix with their filtering and the processing of data quality.
Yeah, actually, one just to add on to this one of the talks that was at the conference I attended last week was about discriminating algorithms and discriminating models. About what are we actually feeding it, and do it discriminate, or do we have biases in different ways? So that yes, it's an interesting topic to dive more into. So. Okay.
Yeah, and again, discrimination could be not on the basis of race, eye color, or etc. Right? The discrimination could be by, I don't know, the car color or the speed that you have had the last year on each of the speed cameras on the
Yep.
highway. Right?
Yes, exactly. There are so many things about depending on what you're using the model for and what you feed it with.
Exactly.
Okay, so yes, just to going back, yeah, the song that was proposed is not machine generated, so it's actually a real song. So that's
Yes, the song.
yeah. But thank you very much, Igor, for doing this presentation, and thank you everyone for listening in here and asking questions. Hope to see you soon in another webinar in a not too distant future again. So take care everyone, and have a very nice day.
Thank you for having me. Bye.